In this video, I will give the introduction to the standard template library and especially the vector. Actually, the full version of the story about the standard template library will be coming at the chapter 17. Chapter 17 is coming after the concept of class design and in front of data structures and algorithms. All these topics more discussed in the CS2 and CS20 courses. In this chapter 7, we just give a little bit of introduction to compare the array structures. Standard template library offers the vector type is one of useful container in standard library and also is superior to the original array structure. Now take a look at the concept of the vector. The standard template library is a collection of data types and algorithms. And data type includes the vector, list, dequeue, set, map, and so on. And also algorithm includes the sort, merge, min, max, and a lot of things is included in algorithms. The data types in STL are also called containers. And we have two types of containers in STL. The first one is a sequence container and second one is associative container. A sequence container manages the data in sequential manner like an array, and associative container organizes the data with key and value pair. The sequential container provides the three types of container. In this chapter 7, we just give the little introduction of vector, and all other types will be discussed in chapter 17. We will practice some code example to manage the vector, and then we can compare the effectiveness and convenience of vector to the array structure. And also, these types belongs to associative container. In these types, all data consist of key and value pairs. These types are commonly used to apply to the deep learning and AI fields. Vector provides the several advantages over the array. First, we don't need to declare the number of elements. The vector size automatically decreases. And also, vector provides the actual number of elements they contain. And now take a look closer at a few examples for the declaration and initialization vectors. Here is the couple of ways to declare the vectors. The first one is to declare the vector without the number of elements. In this case, the vector was declared, but there is no elements in there. The second example is to declare the vector with 10 elements, but the initial number of elements can be changed if we add elements or delete elements. And third example is to declare a vector with the number of elements and also initial value. And fourth example is to declare with the initial values. There is no number of size, just we give the initial values. Here's one thing you need to be careful is that we use the braces instead of parentheses. The basic way of accessing all elements in a vector are range-based for loop and regular for loop. Now I'm going to show the couple of examples to declare and access the vectors. First, we need a new header file. The name is the vector. When we declare the vector, first we have to give the keyword vector and then followed by the data type. It means that this vector has the integer value as an element. In this first declaration, the vector number doesn't have any elements at this moment. This is the way to declare the vector without the number of size. And the second declaration has the number of size. In this case, we have 10 elements in this vector. And then third declaration has also the initial value. In this case, we give the initial value -1. And the first one is kind of a special case. It is declared with another vector variable name. And vector number 5 is declared with the list of initial values. And the final declaration example is another type of vector. In this example, we give the character data type, so the vector name has the characterist value. Now I'm going to make some code to access the vectors. First, I need to check what happens if we access the empty vector. We know the vector number doesn't have any elements at this moment. Now we try to access to print the first element in vector. What do you expect it prints? Compile and run this program. It shows a segmentation fault. It means that it has a runtime error. Now I'm going to make the regular for loop to traverse all elements in vector. First, we need to know the size of vector to traverse all elements. The vector has the member function, the size, which returns the number of elements. Now we can get the number of size by using the member function size, and then we use that value, the number of size, in the for loop in order to make exact iteration with the number of elements. And now let's run this program and we can get the result for the elements in vector number 3. We can also use the range-based for loop to traverse vector elements. It is so convenient because we don't need to be aware of vector size. The vector number 5 has the 5 elements, so it has 5 iterations. Here is the result of this program. We use the two kinds of for loop to access all elements in vector. Now I will introduce a couple of useful member functions for the vector.